What if I told you that there is a computer capable of creating self-healing items for construction and can break down microplastics which cause cancer into harmless byproducts, and even design life-saving treatments that are currently impossible? This might sound like something out of science fiction, but it is becoming a reality. On February 19th, 2025, Microsoft introduced Majorana 1, the world's first quantum chip powered by a groundbreaking topological state of matter. Quantum computing has always promised incredible breakthroughs, but until now it has faced major limitations like instability and high error rates. Microsoft claims that Majorana 1 solves these problems and brings us closer to practical, large-scale quantum computing. And today, we're going to break all this down in a simple and easy to understand way, so anyone can grasp why this matters for the future of humanity. Quantum computing is a completely different way of processing information. A normal computer processes data using bits, which are either a 1 or a 0. However, a quantum computer uses qubits, which can be 0, 1, or both at the same time. This phenomenon is called superposition and allows quantum computers to explore multiple solutions at once, making them exponentially more powerful for solving complex problems. Another key principle is entanglement, where two qubits become interconnected, meaning that changing one instantly affects the other no matter how far apart they are. This gives quantum computers the ability to perform calculations that classical computers would take thousands or even millions of years to complete. However, quantum computing has struggled with major challenges. For decades, researchers have been trying to make quantum computers stable and practical, but there are three big challenges. Qubits are incredibly sensitive to their environment. The slightest disturbance, such as temperature fluctuations or external electromagnetic waves, can cause them to lose their quantum state, making calculations unreliable. Even tiny environmental changes can introduce random errors into quantum computations. Unlike classical computers, which store data in stable transistors, qubits are difficult to control and correct. Adding more qubits doesn't just increase a quantum computer's power, it also makes error correction harder. More qubits means more complexity, making it difficult to maintain stability. Companies like Google, IBM, and Rigetti Computing have been racing to solve these issues. Before Majorana 1, Google introduced the Willow quantum chip, which helped reduce errors exponentially using a scalable approach. But even Willow wasn't enough. Instead of using traditional qubits, Microsoft Majorana 1 is built using topological qubits, which are more stable and resistant to errors. Unlike previous quantum chips, Majorana 1 can scale up to 1 million qubits on a single chip, while keeping error rates remarkably low. Each H structure contains 4 controllable Majorana particles, forming a single qubit. Unlike regular qubits, these structures remain stable even under environmental disturbances, allowing for better error correction and scalability. Quantum simulations in Majorana 1 represent a powerful tool in the fight against environmental pollution, particularly in addressing the pervasive issue of microplastics. These simulations utilize the principles of quantum mechanics to model and predict the behavior of materials at the atomic level, which can lead to groundbreaking advancements in material science. By harnessing this capability, scientists can design new materials specifically engineered to target and break down microplastics into harmless substances. This process not only promises to significantly reduce the impact of these pollutants on marine and terrestrial ecosystems, but also paves the way for sustainable practices in waste management. Moreover, these materials could be tailored to enhance the efficiency and speed of the degradation process, turning what was once a slow and incomplete natural breakdown into a swift and thorough elimination of microplastics from the environment. This innovative approach offers a promising avenue for mitigating one of the most challenging environmental issues of our time. Quantum computing in Majorana 1 holds transformative potential for the pharmaceutical industry, particularly in the realm of drug discovery. By leveraging the inherent capabilities of quantum mechanics, such as superposition and entanglement, quantum computers can analyze complex protein structures and interactions at an unprecedented speed and depth. This allows researchers to simulate and predict the effects of potential drug treatments on these proteins in a fraction of the time it would take using traditional computational methods. The ability to quickly and accurately model protein behavior opens up new possibilities for developing drugs that are more effective and have fewer side effects. Furthermore, this accelerated process can significantly shorten the drug development timeline, enabling quicker responses to emerging health crises and the more efficient treatment of chronic diseases. Overall, quantum computing is poised to revolutionize how new medications are discovered and optimized, potentially saving lives and improving health outcomes worldwide. According to Microsoft, Majorana 1 quantum computers offer an innovative approach to material science, particularly in the development of self-healing materials. These advanced materials have the potential to revolutionize the construction and automotive industries by enabling structures and vehicles to repair themselves automatically. Leveraging the power of quantum computing, scientists can simulate and manipulate the molecular dynamics of materials to create compounds that can react to damage by restoring their original structure. For example, in the construction industry, this technology could lead to buildings that detect and repair cracks in their foundations or walls without human intervention, significantly enhancing their durability and reducing maintenance costs. Similarly, in automotive manufacturing, vehicles could be equipped with materials that fix scratches or dents automatically, preserving aesthetics and structural integrity. The use of quantum computers accelerates the design and testing of these materials by handling complex calculations at speeds unachievable by classic computers, paving the way for smarter, more resilient infrastructure and products. Quantum computing is no longer just theoretical. Majorana 1 marks the beginning of a new era where quantum computers can solve problems faster and more efficiently than ever. Like, subscribe, and stay tuned for more tech breakthroughs. See you in the next one.